Hi everyone, it's Mr. Baker here, and we're doing another physics video. Thought we'd have some crazy fun today, and see if you can guess what the title of today's lesson is. So we've got something to press, plus not mine, but we've got some of the picture here, and we've got this. So let's see, can you guess what it is? Okay, so press, and not mine, but your. So press your pressure at a, we've got these two pictures here, pressure at a surface, pressure at a surface, pressure at a surface. Yay! So that took a long time. Let's move on to the lesson. Okay, so today, yes, we are looking at a pressure at a surface. You're going to be able to state the factors that affect pressure and how it's caused at a surface. Be able to describe how changing the factors will affect the pressure and use some units, these SI Standard International units, and you should be able to perform some calculations as well. So have a look at this picture. Describe what will happen next. Dun, dun, dun. So actually, if you've got a load of pins like that and you put them put a balloon on top, you can actually exert quite a lot of force without it popping. I'll show you another example. So this is some nails and we've got a balloon, and actually the balloon won't pop. You can try this at home. If you've got a balloon and a pin, it will pop, but if you've got a balloon and loads of pins that you can put down, then you should find that it's a lot more difficult to pop. So why is that? So when there are more pins, the balloon doesn't burst because the pins create a larger surface area. So one pin, really small surface area, so a large pressure, and so it'll pop. But when you've got lots and lots of pins, they create a larger surface area, and so the force is spread out, so the pressure is reduced across the whole of the surface of the balloon. Okay, so how does gas exert a pressure at all then? So if we have a look at this diagram here, we've got these molecules and they're bouncing around and they're hitting the surface, and that's basically how it exerts a pressure. So if you have a gas consisting of molecules going in constant random motions, when a molecule collides with the surface, it reverses due to reverses direction, due to the force exerted on it by the surface. So the molecule will go in and reverse direction, basically it will rebound off there. And every time it rebounds, it will exert a force. So the surface exerts a force on the molecule, and the molecule exerts a force on the surface. And it's that force over the whole of the area of that surface from all of these different molecules that causes the pressure. And if you can remember, pressure equals force over area. So with all those different forces going on that surface, which whatever the surface area is, force over area equals the pressure. Right, so we've got lots of examples here of different places and different pressures. So if we look here, first of all then, so at sea level at 0 degrees, we have 101,325 pascals. Okay, so that is the pressure that we sort of walk around in every day. If we were to go up to the top of Mount Everest, then it would reduce down to almost about a third, 30,000 pascals, 30,000 newtons per meter squared. Typical tyre pressure in a car might be 180,000. And if you just go 10 meters under the sea, it'd be 200,000 pascals. And if you go down 3.8 kilometers under the sea, then it'd be 41 million pascals, 41 million newtons per meter squared. But if you're in space and where there are no particles, then the pressure would be 0. So a few other examples of units of pressure that you don't need to particularly know, but you might just see. So we've said that 101,325 pascals is the pressure that we sort of walk around in at sea level every day, and we call that, because of that, we've got 1 atmosphere worth of particles above us, and so we call that an atmosphere. Okay, so it's easier because it's just 1 atmosphere, and so we can talk about atmospheres then, and it's fairly standard. So that's a nice one to use sometimes. Bars and millibars. You might see this kind of diagram on weather reports, and so we might talk about pressure in terms of bars and millibars. Other types that you might have seen. So if we use SI units, Standard International units, which is the same as sort of the whole of Europe and some other parts of the world. But some places like America, for example, use imperial measurements. So they might use pounds per square inch. So 1 atmosphere, which is 101,000 pascals, is 14.7 pounds per square inch, PSI. So you might see that. Another one you might see in things like barometers and things like that, especially, are inches of mercury. So this is a barometer that might be able to predict, that will might tell you what the weather's like based on the pressure, and it would be measured in inches of mercury. So we've said that pressure is the force divided by the area, and we could say then P for pressure, F for force, area is A. Force is measured in newtons, area is measured in meters squared, pressure is measured in pascals. And so we might use a triangle that looks like this. So pressure is force divided by area, so I cover over the P, F over A, force divided by area. If I want the force, I cover over the F. F is P times A, pressure times area. And if I want area, it's force over pressure, force divided by pressure equals area. And just note, we've talked about pascals and newtons per meter squared. 1 pascal, which is the unit of pressure, is the same as 1 newton per square meter. So you can use newtons per meter squared, or you can use pascals, as long as you know that 1 pascal is the same as 1 newton per square meter. Right, so this is the type of experiment that you might do at school. You might try and find out the pressure that you're exerting on the floor. So the way to do that would be to weigh yourself, draw around your feet, measure the area of your feet. So if you do it on graph paper, you can count the squares. You'd have to convert your area into meter squared if you want to do it in pascals, otherwise you can leave it as centimeter squared or whatever. And then you can calculate the pressure using the equation pressure equals force divided by area. So that's something you could do. And the kind of results you might get might look like this. So let's say the person that did this was 50 kilograms, so they're about 500 newtons. And when they drew around their feet, there was 60 centimeters squared, which is 0.006 meters squared. So the pressure is force divided by the area, 500 divided by 0.006. So they would have a pressure of 83,000 pascals. So you could see if you did this, if you got a similar kind of result. Right, and a kind of question that you might have is, why do off-road vehicles have large tyres or large tracks? And so it's really to do with the surface area. So if we want to have the smaller pressure, then we want to have a larger surface area. So if this is our equation, pressure is the weight or the force divided by the area, then making this here as big as we can will reduce the pressure down. And the lower pressure means the vehicle doesn't sink into the ground. If it was mud or sand or something like that, it won't go down, and that's what we want for off-road vehicles. Okay, so we've looked at these things then. So we've said what factors affect pressure and how it can be caused. We've described the factors that affect pressure and the different units, and then you've had a look at some questions and things using the equation as well. So that's the lesson over. Thanks very much for listening. I've been